Hello friends, welcome to the today's session. Our today's session is on discussion on joins. What is the importance of join and how joins are very much useful while writing the programming, especially in backend, and what are the important questions are going to come in interviews and what kind of questions are going to be asked in GATE and PSU examinations we will discuss in this lecture. So welcome to today's topic joins. So before going into details, our anthem is Crack Gate and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded courses from India's topmost educators. About myself, Srinivasarao Sir is a well-known GATE faculty in the subjects of DBMS, computer networks, and operating system. Having 17 years of GATE experience, also had good certifications in the same field. Throughout my journey of GATE, I taught in many premium academies, including MEDICE 2 with a high success rate. So, in order to get the admission into an academy, use my referral code Sankara to get 10% off either in 12-month subscription or in 24-month subscription. Let's crack GATE CSC, subscribe to our YouTube channel and use my referral code for any kind of admission. Well friends, now let us start what is the importance of joins. When you talk about a join main intention, to share the data each other or retrieve the data from multiple table instances. It may be a single instance can be make it a multiple forms or multiple table instance can be utilized in order to retrieve the data. So joins are very much useful in order to get the data from multiple tables. So what are the types of joins we have in SQL? I'm talking about as per the standards of Oracle. So we are also going to learn as per the standards of Oracle because your GATE exams are mainly focused on SQL based Oracle only. Therefore, there are two types of joins we have. One is inner join, the other one outer join. So when you talk about inner join and outer join, why we are making versus means inner join mainly based on matching data. Outer join is mainly based on matched and unmatched tuple set. So the other type of join is called two-way join and n-way join. Two-way join is nothing but where you could see that two instances are being shared in order to get the data, where in n-way join you see that multiple table instances are used to get the data. So the inner join, when you talk about inner join, it mainly deals with common tuple set. Inner join mainly deals with common tuple set. That means there is a mandatory requirement common column in this. That's what the meaning of inner join. So what is a mandatory condition? Common attribute sets are required. Common attribute sets are required. Otherwise, we cannot perform inner join. So what about outer join? When you talk about the outer join concept, you please understand clearly it deals with two types of information. It try to bring common data as also it try to bring uncommon data. You can also call it as spurious tuples, also called as Dangeling tuples. So mainly outer join is going to deal about common data as well as the tuples which are unmatched. We are also discuss on that, how it is going to be helpful in order to bring unmatched tuple set, also called as a Dangeling tuple set. Well friends, So this is the straightaway definitions for inner joins and outer join. If you look at the other type of join, that is two-way joins and n-way join. When I am talking about the two-way join, the join is in between. You can say that two instances. I say in join there is a R and a S table are involved. R and S tables are involved in joining. So if I am talking about n-way join, you can say that multiple instances, either it may be three-way join or four-way join, all the kinds of the things will come into this. For example, I say RST are the three table instances are involved in order to share the data. So we mainly look at the joins concept, especially in primary key versus foreign key. Sometimes we also use, in the absence of primary key and foreign key, we also try to retrieve using the concept of unconditional joins. So unconditional joins, we're also calling them as a non-equi joins, also called as a theta joins. We will look at very sooner. So as far as Oracle standard concern, there are mainly two types of joins are there. One type is before 1999. They are not a shorthand join, so you have to write the complete keyword. The other one is called after 1999 join. So you observe that what is the difference between these two varieties? I'm talking about Oracle side. You see that the first variety of join there is a cross product, and the second variety of join is there natural join, and third variety of join is there join using on, and the next variety of join is called outer join. The beauty of outer join in before 99 base few varieties. One, you can have a left outer join. I said that outer join is nothing but it try to bring the common data as well as spurious tuples, also called as Dangeling tuples. Left outer join. We have also right outer join, and the third we have also full outer join. Three types of outer joins are there. In that, full outer join is very important for us, which was one of your previous GATE question in 2015. And what is the difference between before 99 and after 99? It's completely keyword based, and this is completely shorthand based. You can write the queries using just operators. That's why they are called as shorthand based joins. Simply, it is going to be represented in the form of operators. But here, you need to write the complete keyword in order to represent a cross product or natural join or outer join. You need to write completely that complete keyword. But in after 1999, the keywords are being represented in the form of operators. Simply, you can use the operator in order to equalize those kind of before 1999 joins. So let us see first of all what is the cross product, natural join and join clause and outer join in this lecture. So when we talk about the first kind of a join is called cross product. So what is a cross product? You observe that cross product is nothing but all rows of one table instance, is mapped with all rows of other table instance. So in that, every time I'm going to take a database. Based on the database only we are trying to solve the examples. So that's why every join has minimum and maximum representation. Please don't forget, again I am repeating, every join has minimum and maximum representation. Here Cartesian product also, why we are putting under a join in the sense, because you try to retrieve the data from multiple instances. That's why cross product is also called as a join in this, because the ultimate objective of join is nothing but get the sharing of data. So here I am representing cross product in this way. That's nothing but R cross S. Here I am using a two table instances, and so you have got R cross S. So what is the minimum cross product? minimum of R cross S and what is the maximum of R cross S, we will see. So these are very, very important shorthand questions. What is the minimum cross product value? What is the maximum cross product value? Which was also asked in the previous GATE examination. So minimum R cross S is 0 and maximum R cross S is M into N. Please observe this, you can also write in the form of Mn. Why? Why it is called as 0 as a minimum representation and why it is called as M into N in the maximum representation? We will look into this. So let us take one example carefully. So what is the cross product? If I am saying there is a relation R which consists of A and B tuples, two attributes are having a tuples like this. So 10 and B1 and 20 and B2. And there is a table instance, yes, I am having C and D. And there are some tuple sets I am saying here, for example, 100 and D1, 200 and D2. Now, if I am asking what is your R cross S, I can say that your two tuples are going to be mapped with other two tuples. Then you are going to get answer as how much, friends? 4. That's why the maximum, I said that it is always in the form of M into N. If I am saying what is the minimum, so minimum example you look at carefully. I am saying there is a R which consists of A and B. The data is 10B1 and 20B2. I say there is a S which consists of C and D and no tuples are there in that. Please observe carefully. No tuples are there in S. Now if I am asking what is R cross S, your answer is 0 because I cannot able to map any of your relation instance S tuples. That's why R cross S always will have minimum as well as maximum size of the representation of the join. So minimum is 0 and the maximum it is going to be represented in the form of M into N. So what kind of questions we expect on this kind of cross product? Let us see. So this is how the examiner may ask you. For example, I say let R has 10 tuples, comma, S has 20 tuples. Observe carefully, friends. And T has 0 tuples. If I am asking you the first question, what is R cross S? Now you can all say very clearly that 200 mappings you are going to get. This is the maximum. If I am saying what is R cross T, your answer is 0 mappings. And what is your T into S? We can say that it is also 0 mappings. If I am saying R cross S cross T, your answer is also what? 0 mappings only. Why? Because the other table instance do not have any kind of tuple set in order to map them. That's why the necessity is that there doesn't require any kind of common column for cross product. Cross product is why I kept in joins is it is trying to share the data which doesn't require any kind of common column. Common column requirement in order to avoid the cross product. Please observe. I want to get the sharing of data, but in order to avoid the duplications, because cross product main drawback is duplications only. To avoid the duplication, there is a requirement of what? Common column. So common column is trying to avoid the duplicity which are coming from cross product only. That's why, friends, whenever you try to retrieve data from multiple instances, the first executable join is cross product only. That you don't forget. Now come here. So I'm saying there is a department instance and there is an employee instance. This is a department number which I am having 10 and 20. And employee instance, employee number E1, E2. And I say that what is your department cross employee? Now I'm saying that DNO you are going to get there and ENO you are going to get there. Now your combinations are 10E1 will come once again and 20E1 will come once again. 10E2 is going to map, 20E2 is going to map. Therefore, what do we understand? We are going to see some kind of duplicity in your representation of sharing of data. So in order to avoid this kind of duplicity, there is a requirement of what? A join condition. So the main purpose of join is nothing but what? Getting of the data from multiple instances at a time. But to avoid the Cartesian product, there is a requirement of what? A valid condition. So please observe, friends, what is the rule? What is the rule of Cartesian product? Rule of Cartesian product is nothing but when we retrieve data from multiple instances, then it is Cartesian product. This is the concept of Cartesian product. So we want to see that the drawback of Cartesian product is redundancy. So in order to avoid this redundancy, there is a mandatory requirement of what? Joins. So joins are trying to do what I mean to say. This point we want to write here that to avoid redundancy, join is required. Clear? So in order to avoid redundancy, we start coming with the concept of join. So in the first variety of join, in order to avoid the duplicity which is coming from your Cartesian product, the first variety of join is called natural join. This is a very, very important natural join concept. The representation of natural join is like this. So are natural join? Yes. So what is the meaning of that? There are few important rules with natural join. One is that, so first let me explain elaborately, then I will provide you shortcuts. First let me explain what is a natural join. So natural join are looking for common attributes. And if you able to identify common attribute, immediately we want to see that common tuple set. And point number 3, after mapping common values, eliminate duplicate attribute set and duplicate tuple set. That's it. So how you can write your R natural join? Yes, please observe, friends. The first step for any kind of a join is a cross only. Don't forget that. The first step for any kind of a join is a cross. First R cross yes we will perform. On that we do selection based on common column. On that we do projection, which is try to avoid these two. So projection is responsible for this important point. What is that? Elimination of duplication attributes and elimination of duplicate tuple set. So the first condition is R cross S only. On that we are going to implement the selection. This is your second step. On this we are going to implement third. So this is for common data representation. This one is for mapping all the tuples. So to perform any kind of a join, cross product is compulsory and mandatory. Now let us do how natural join could be worked on. So I am taking now, there is a department instance which has got department number 10 and 20 and 30. I say department name, and we have sales department and accounts department and marketing department. Please observe, friends, every time I change the database instance, please observe carefully. I am having employee instance and employee number I have E1 and E2 and E3. This department number I am going to use here as one of your common attribute. I say he is working in 10, he is working in 20, he is working in 10. Now if I am asking you, select, please observe, friend, select asterisk from department. How many tuples you are going to get? You can respond through chat. Select star from department. As per as the last class knowledge I am asking. Select star from department. How many rows you are going to get? 3 rows you are going to get. If I am asking one more query, that is select star from EMP, how many rows you are going to get? You are going to get how many rows? 3 rows from this. Now, you also please observe here, if I am asking both at a time, so I am going to merge this time employee and department data. Therefore, how are you going to get? If I am asking a query, this is the first query, this is second query, and this is third query. If I am saying that select asterisk from EMP comma department, how many rows you are going to get? This is very important. Select asterisk from EMP comma department. How many rows we are going to get? All of you. Select asterisk from EMP comma department. I am getting data from employee. I am also getting data from department. So how many rows we are going to get? So we are all thinking that data is coming from employee and department. We see that the answer is how much? 6 rows. But it is wrong. Why it is wrong? Because we are using the concept of whenever you're trying to bring multiple data instances, it is a concept of cross product. That's why I shared initially why we learned cross product initially, because of that. Whenever we retrieve data from multiple instances, then it is a cross product. Therefore, your answer is not a 6 rows here. Your answer is a what? A 9 rows. Why we got 9 rows? Please observe, friends. This 10 will map into this, this 10 map into this 10 will map into this will map here, this will map here, this will map here. In the same way, this is going to map rice. So therefore, 3 rows of employment and the multiplied with 3 rows of your department, you are going to get a 9 rows. So now, in order to avoid that duplicity, we are trying to implement a concept of natural join. So how I'm going to write? Observe carefully. The fourth query, I am using natural join now. I say select asterisk from department, natural join. See, I am writing before 99 joins only. When you are writing before 99 join, you have to use it compulsorily what? Keyword, cross product, natural join, outer join, likewise keywords you have to use. Natural join, I say select star from EMP. Now friends, what is your answer? First, you are going to get department number and the department name, and you are going to get employee number, and you are going to get, what is the next column here? A department number. Now you observe carefully. The first 2 columns are coming from department table. The next 2 columns are coming from employee table. Now here, how the data is going to come, let us see. So the common column here and there is your department number only. That's what our main intention. That means the mapping is going to happen this time on department numbers only. It doesn't mind any other column, because between department and employee, the common column is a what? Department number only. It considered all common columns, but we have only one common column here. Now the mapping is based on department number. Now you observe, this 10 can map with this 10, this 10 can map with this 10. Therefore, you're going to get 2 rows, 10 sales E1 10, 10 sales E3 10. That we are going to write. 10 sales E1 10 and 10 sales E3 10. Now you observe, friends, one more. So this 10 mapping is completed. Come to 20 mapping. So 20 cannot map with 10, and it cannot map with this 10, and 20 can map with only this 10, 20 only. Therefore, 20 accounts E2 20 we are going to get. So we get 20 accounts E2 20. That's it. This is your natural join, because you do not have any kind of mappings on 30, so you cannot get it. Therefore, you observe, if you do cross product, your result is 9 rows. From the 9 rows, we have removed your duplicity of the data. Now from natural join, you understand that your answer is only 3 rows. This is the power of a join. We try to retrieve the data, combination of data, without having any kind of redundancy. That's what the use of natural join. And what the natural join is also going to do, It eliminates duplicate tuples, also eliminate duplicate columns. So the duplicate column is this one only. Already it is presented here. You remove this. And there are no any duplicate tuples in that. So you will get final answer as department number, department name, and employee number having only 3 rows. Clear friends? All of you. Clear now? So this is how you can able to provide a concept of non-duplicity of data, but our motto is satisfied. What is our objective? Get the data from multiple instances. So natural join also has a minimum and maximum. Why? I will show you. Now you observe carefully. I'm saying, I'm changing the database now. There is a R which consists of AB. There is a S which consists of AC. Now I have 10 B1 here, 20 B2 here, 30 C1 here, 40 C2 here. My first question is, what is your R cross S? How many rows? All of you, what is R cross S? What is R cross S? How many rows? How many rows? R cross S is nothing but your R and S are going to be multiplied. Therefore, you are going to get how many rows, friends? 4 rows. And the second one, when I am calling R natural join yes, please observe. When I am saying R natural join yes, there is a common column. Natural join always looks for common column. There is a common column A. Now 10 is going to map, it is not possible. 10 is going to map, it is not possible because the data is not common. 20 is trying to map, it is not possible. And 20 is trying to map, it is not possible. Then our natural join yes will give you how many here? 0 rows. See the difference between cross and natural join. Okay. Now let us see one more example here. I am saying there is a R and there is a S. I say AB here, C and D here, and the data is 10 B1, 20 B2, 10 D1, 20 D2. What is your R natural join yes? How many rows? What is your R natural join yes? Please observe carefully. This is a very, very important example. What is R natural join? So we are all getting what is our R natural join yes, friends? How many? R natural join yes. How many? Your answer is 4 rows. Your answer is 4 rows. So some are guessing that 0 rows, some are guessing that 2 rows, but your answer is what? 4 rows. Why is it a 4? Question mark. That we will see after some time. Now you got my point. See that many things you need to learn in the joins concept. Why it is a 4? I will reveal why it is a 4 after some time. Just follow the lecture. Now I'm saying the next example like this. I say there is a R which consists of ABC here. There is a S which consists of ABD here. I am giving some data tuples here A1, B1, C1 and A2, B2, C2. Here I am writing A1, B2, D1 and A1, B1, D2 and A2, B2 and D5. Now, if I am asking you, what is your R cross S? Your answer is 6 rows. If I am asking, what is R natural join S? How many columns? How many rows? This is a very important representation, friends. Understand carefully. Natural join always looks for common attributes as many they are between R and S. It's a mandatory condition. Therefore, here your common attribute is here AB, your common attribute is here AB. Therefore, mapping is going to happen between these two. Therefore, you see that A1 B1 combination, A1 B1 combination. So you will get one row. And one more, A1 B1 cannot map to A1 B2, A1 B1 cannot map to A2 B2. It's gone. Come to next combination. A2 B2 cannot map to this, cannot map to this, but it can map. Therefore, 1 plus 1, that is equal to 2 rows you are going to get. So number of columns, how many columns you are going to get? I said that you are going to get columns like A, B, C, A, B, D, but it eliminates the common columns, and so you're going to get the columns are only 4, A, B, C, D only, and number of rows are 2. Here, this time, the manipulation is happened between A, B columns together. Please understand, friends. The manipulation is happening between A, B columns together because A, B is a common in this case. Okay? So come to the next example. The next example is when I am saying RAB and I say yes A and C, and there is some tuple set is existed 10B1 and 20B2, and I am saying here 30C1 and here 40C2, and we are all guessing that our natural join yes is going to give you 0 rows. Even though the column is a common, we do not have equivalent mapping. This example we already seen. I am extending this example to like this. I say there is a R which consists of A, B and C. There is a S which consists of A, B and D. Now I have some tuple set here. I say 10B1 C1 and 20B2 and C2 and 10B1, better let me give 10B4 and D1, and you have 20B1 and D2, and you have 10B3 and D3. Now you observe carefully, friends. If I am asking you R natural join yes, your answer is how many? 0 rows. Why your answer is 0 rows? Because this time the mapping is done on AB. Clear? Therefore, 10B1 is not at all available other side. 20B2 is not available at all other side. Then therefore, your value is 0 rows. But that's why, what is the problem with the natural join? Let us see. Natural join, when you talk, advantage is so non-duplicity of data, no doubt. Non-duplicity of data you are going to get, and one more advantage is that it is a strict join. It is a strict join which consider all common columns. That's the main drawback of natural join. It consider all common columns in order to do the mapping. So what is the disadvantage? The disadvantage is that only because of strict join. Because of strict join, we cannot map tuple sets. We cannot map tuple sets. So this problem can be avoided in the third variety of join. What is the third variety of join? Join on clause. Join on clause. So how to write this? I am writing select a star from R. Please observe, friends. Join table S on. You have to write on which column you want to do mapping. For example, if I want to map on A, then what is your answer? A, B, C. Please observe carefully, friends. A, B, D. From the previous diagram I am talking. Come to the previous diagram. What is the previous diagram? This time I am mapping on to A only. Observe. I am ignoring the second common column. The ignorance of the other common columns is the concept of join using clause. So join using clause is nothing but whatever common column you want to use for the mapping, you can use it. The remaining common columns are ignored. This time I am doing mapping on only A only. Therefore, this 10 can map to this 10 This can map to this 10, and this 20 can map to this 20. Therefore, you are going to get almost all 3 tuples. So our answer is from this, how many tuples? 3 tuples we are going to get. Why 3 tuples? 10 is matched one time with this 10, and this 10 is matched one time with this 10, and next this 20 is matched here 20. So this is how you have got tuple 1 here and tuple 2 here, tuple 3. But whereas the same database I have used, but what is your answer here? 0 rows. Why? Because natural join consider all common columns. You want to ignore any kind of a common column, instead of using natural join, better you opt for that is a join using on clause. Okay, so let me write one more example so that you will get the clarity. So what is the power of join using clause? Observe friends, it try to identify the required common column mapping only. The remaining common columns are going to be ignored. Okay, let me write one more. I am saying a relation R which consists of ABC here. I have like A1, A2, B1, B2, C1, C2, and there is a S here. I am saying ABD, and the data I am giving like this: A4 and A6 and A7, B1, B7 and B2, A8 and B1. So we don't mind about that. You may have any kind of data in other columns. Now, if I ask you, R natural join yes, how many rows you are going to get? If I'm asking R natural join yes, how many rows you are going to get? Question mark, you can fill my answer. Now I am writing a query here that select star from R, join table S on B. Now how many rows you are going to get from this? You can answer to my question. How many rows for R cross R natural join yes, and how many rows are here? Select star from R, join table S on B. So how many rows we are going to get? So R natural join yes, when we are asking, so it consider all common columns and all common columns. So no mapping is there and there. Therefore your answer is what? 0. But here I am mapping on only B. I am mapping on to only B. Therefore B1 can be mapped, and B2 can be mapped, and B1 can be mapped. So we got 3 tuples here. So this is the difference between your join using clause and natural join. Okay friends, so come to next representation. I am writing like this. You see, when I am talking about a natural join versus join using on, both are same. They map on common tuples only. Common tuples and common attributes. But in the second variety, you have some relaxation. You have some relaxation here. I will represent now, understand. Let us say R of ABC is a table, S of ABD is a table. How you can represent R natural join S? Observe friends. Now I am writing the pseudocode how you can able to represent R natural join yes, and I will also write the pseudocode for join using on clause. Okay, how to represent R natural join yes? Please understand. First, what is that? Cross product is required. This is mandatory. Don't forget that. First step for any kind of a join is cross product only. On that I am doing selection. What is your selection? Selection based on all your common columns. There are 2 common columns here and there. So I am writing here in such a way. Please understand. R dot A is equal to S dot A, and one more condition. R dot B is equal to S dot B. On this, we are going to remove what? Duplicates using projection. Okay. Now I will represent R, this join using clause. It's nothing but R is going to map it with yes, but on required column. So how you can do this? Same. What is that? First step is R cross yes. Second step is a selection. But this time selection is based on the required common column only. So I am writing here R dot B is equal to S dot B. On that we are going to eliminate what? Your duplicate. So this is the difference between the implementation of natural join and join using on clause. So as many common columns you want to write, those many you can write using join. And natural join is a compulsory that it automatically consider all the common columns. But in join using clause, you have to write manually that what is the common columns you are going to use it. Okay, friends. So this is how to implement our natural join yes. This is how to implement our join using clause with yes. Come to the third variety of join, that is conditional join. This is your 2012 IIT GATE IIT Delhi question, conditional join, also called as theta join. What is the meaning of this? Join is based on uncommon column. That means join can be established even there is no common attribute. This is what is the power of conditional join. So how this conditional join can be proved, or also it is called as a theta join. How this can be proved? Please listen carefully. Concentrate here. I am saying there is a R. R in the sense you can guess course table or student table or employee table, department table, books table, author table, anything. But I am writing in a shorthand notation. There is a table S which consists of C and D. Friends, observe carefully. I am saying 10B1 here, 20B2 here, 30B3 here, and I am saying 10D1 here and 40D2 here, and I am saying 30D3 here. Okay, the first question is R natural join yes is equal to how many rows? Next one, R join yes by mapping using B, how many rows? All of you, please guess my answers. These are all typical examples I am providing you never get from any kind of materials. Please observe. What is your R cross yes? Please respond. What is your R cross yes? I am writing here natural join. Please observe. This I am writing join using on clause. So how many rows in this? How many rows? How many rows in R natural join yes? All of you, please respond. How many rows in R natural join yes? And how many rows in R natural join with mapping B? Our answer is R natural join yes. How many rows? How many rows? 1, 2, 3. It's nothing but 3 into 3. We are going to get a 9 rows. And R mapping with B, it is also giving you how many rows? 9 rows. Why 9 rows? Because why 9 rows? Because there is no common column available. This is the secret I want to reveal. What is the secret? Observe now. If there is no common between R and S, please observe. If there is no common between R and S, then your natural join automatically belongs to R cross S. This is the secret. Please don't reveal any of your friends this kind of secrets. Please observe. So this is a very, very, very important question in GATE. When there is no common between your joining relations, then your R natural join S or R natural join with the B mapping also will give you what? R cross S only. All of you clear? So this is secret behind why it is giving cross product, why it is be giving cross product. There is no common between R and S. Different columns are there. I am not talking about data may be common, but common column should be available for the mapping. Whenever there is no common column is available, then you say that your R natural join S is what? R cross S only. So in this kind of case, we want to see that cross product to be avoided. That can be done only using a word theta join. Please observe, this problem can be avoided in theta join. Even though you do not have a common column, but we could able to do mapping of data using a theta join. How to be done? I will show you. Please observe. I say there is a table R which consists of AB, 10, 20, 30, B1, B2 and B3. There is a table as 10 D1, 40 D2, 30 D3. Observe friends. Now I am saying C and D and here A and B. So I cannot establish natural join here. Why you cannot establish natural join here? Because there is no availability of the common column. It's because you observe carefully, natural join and join using these two are belongs to inner joins. Please observe. Those two are belongs to inner join. What is inner join? Inner join looks for common attributes and common tuple set. Now I am writing the different variety. See that. I say R is going to join with S. So please observe. So what is audience question? Cross of A, same tuples. Yeah, clear, right. Now you observe. So you're asking about previous example now. You will get 9 rows, you will get 9 rows because B is also not a common column here and there. It's not at all having a common column. Hence, it's a failure of the common column representation. Hence, it is automatically we use same tuple set, 9 rows and 9 rows only. Okay. So come to next example. So R, I'm crossing with S. You see carefully, I cannot put the natural join because there is no common column between your R of AB and no common column between your this. Now I can able to avoid the cross product. So to avoid the cross product when there is a no common column, then you can use this. I say that your R dot A greater than, for example, any condition you can give, valid condition it's supposed to be S dot A. Okay friends, now let me write clearly your 4 columns here, A, B and C, D. Why I am writing your 4 columns and 9 rows? Because any kind of a join, the first step is a what? Cartesian product or cross product only. So I am mapping them 10B1 and 10B1 and 10B1, and you will get other two tuples 20 and 20 and 20. Next you will get 30 and 30 and 30. Please see. Now I am saying 20 with B2 is going to map with 3 times with others, and 30 B3 is going to map 3 times with others. You have 10 D1 here and 40 D2 here, second mapping. 30 D3 is the third mapping. Again 10 D1, 40 D2 and 30 D3. Again 10 D1 40D2 and 30D3. Okay. Now the mapping condition, this is your mapping condition. What is that? R dot A must be greater than S dot A. So greater than S dot C. Now R dot A is greater than S dot C. This is the condition. R dot A greater than S dot C. Now you tell me which are going to come now. So this 10 is not greater than to this 10. Hence it's gone. First mapping is gone. Second mapping, this 10 is not greater than to 40. It's gone. 10 is not greater than to this 30. Please observe here and there I am mapping. It's also gone. This 20 is greater than to this 10. It will come. 20 is not greater than to 40. 20 is not greater than to 30. So this will come and this will not come and this will not come. So you are going to get how many rows, friends? Only 2 rows. So you observe, even though there is no availability of the common column, then you are going to get a cross product. That cross product is being converted into a suitable values to us. So you got only 2 mappings only out of your 9 mappings. Therefore, your cross product can be avoided even though there is no requirement of common column. So even though in the absence of common columns, you can get 100% equivalent tuple set just by using a valid condition. If condition success, then mapping also success. Clear, friends? Right? So now I am moving on to next variety. That is outer join. So what is the concept of outer join? The concept of outer join is it takes common data if available. It takes common data if available and unmatched data plus unmatched tuple set. There are 3 flavors. One is left outer join, right outer join, full outer join. So all of you don't miss evening questionnaire. We are going to deal with this concept, theoretical concept only, what we are learning. I will provide you shortcuts. Wait till the end of the class. So left outer join, right outer join and full outer join. What is the representation of left outer join? R natural join yes and left remaining. That's the meaning, left outer join. Right outer join, R natural join and the remaining tuples of other side. So face is looking other side. So what is the full outer join? R the availability tuples of both sides. This is the representation, 3 different varieties. So in first case what will happen, second case what will happen, third we are going to learn. So let me write data now. I say that there is a R which consists of AB, 10B1, 20B2, 30B3. I have S, A and C, 10C1, 20C2 and 10C3. If I am asking what are left outer join yes, this you can write in a symbolic way, that is select star from R left outer join yes. This is the keyword you have to use. Clear? Now what is the meaning of that and what kind of tuple set we are going to get now? You see R left outer join yes. This is left outer join. First you are going to get the 4 tuple sets here. AB, AC. You see now, observe carefully. Please look at the board. So A and A this time, because I'm asking you first natural join only. From natural join, it is extending like this. So first natural join is mandatory. Therefore, what do we understand? Natural join, left outer join is nothing but what? R natural join, yes, plus the remaining tuple at R side. That's the meaning. First common data it will give, then unmatched tuple set which is available at R also it will display. How? Let us see. First, this 10 can map with this 10 and this 10. So you got 10B1, 10C1, then you got 10B1, 10C3, then this 20 can map to this 20, that is 10B2, 20C2. Now you see that 30 do not have mappings. The tuple set which do not have mappings is 30, that 30 you write. 30B3, I do not have mappings, bus. Okay, so this is how you can able to write left outer join. This is the extra tuple you got. First three tuples are natural join only. The extra tuple set you got because it does not have any mapping with S. This is your R and this is your S. You do not have any kind of mapping with S. So we got 4 rows. Clear, friends? Let me write one more example. If I am saying there is a R which consists of AB and there is a S which consists of A and C, I say 10B1, 20B2, 10C1, 40C2, 50C3. So what is your answer? This time I am writing R right outer join yes. So what is R right outer join yes? Write all your 4 columns, that is AB and AC. Observe carefully. First common data you write. What is the common data? A and A are the common columns to us. So I am writing common data. This 10 can map with this 10. So 10B1. This is R. This is S. So 10B1, 10C1. And 10 cannot map with others. 20 cannot map with others. Now you observe. So this 40C2, 50C3, we are looking other side. The tuples which are remained in the S which are unmapped with R. So 40C2 do not have mappings with R. 50C3 do not have mappings with R. This is the representation of R right outer join yes. Okay, friends. Now I want to write full outer join now. Now let us see. R full outer join of yes. That means first R natural join yes. Second one, the left side remaining data. Third one, right side remaining data. All three together will come. Now I am giving you an example here. R consists of AB, 10B1, 20B2. S consists of AC, 10C1, 30C2. If I am asking what is R full outer join yes, your answer is 4 columns, that is AB, AC. Now I can write first common. A is a common between them. So 10B1, 10C1. Then left side remaining 20B2 null null. Right side remaining 30C2. This I can write by eliminating your common column, that is A and B and C. Please observe now 10 B1. This 10 I have eliminated C1. Next 20 B2 and null. This 10 I eliminated. Next you got 30 and null and C2. So wherever value is present, that value just I filled in A and remaining null value just I eliminated. This is the final output of your full outer join. Okay, friends. So 10B1 C1 10b1 c1, next 20b2 and other side null, and next one 30c2 null. 20b2 do not have mappings, 30c2 do not have mapping. That's what 10b1 mapping and 20b2 do not have mapping. 30 and this one 30c2 do not have mapping. So now come to the point. So finally we learned before 1999 joins, they are cross product, natural join, join using on, next one conditional join, next one outer join. These are all done. So now we will see after 1999 join. After 1999 join, the first one is Cartesian product. Point number one, it is similar to cross product. It is similar to cross product. Point number two, minimum comma maximum size of join is 0 comma m into n, no doubt. There is no difference here and there. It's also very similar to cross product only. We are calling it as a Cartesian product. No keyword to represent Cartesian product. But in before 1999 join, we have a keyword. What is the keyword? Please observe. There is a keyword called cross product. We don't have a keyword here. And here there is a keyword called natural join. Please observe. Now we will see an example here. Example for Cartesian product. Yeah, both are same. Cartesian product and cross product both are same, but here we don't have any keyword like cross product. But in that cross product keyword is there, cross CRO, SS, PRO, DUCT. Here no, we need to represent a shorthand. They are all shorthand joins. When I am talking about after 1999 joins, they are shorthand joins only. They are shorthand joins. We don't have any kind of keyword there. So Cartesian product, now I am asking you, department and employee which has got 2 rows and which has got 2 rows. If I ask select star from, let me give 3 rows. If I ask select star from department, you will get 2 rows. If I am asking select star from EMP, you will get 2 rows. We know the last which were the variety which I am going to give, you can guess. That select star from department comma EMP, how many rows? Select star from department comma EMP, how many rows? So you can guess. Is it 4 rows? How many rows? Is it 4 rows? Is it going to give you combined data of department and employee? Is it 4 rows? Is it 4 rows? Our answer is no. Your answer is what? 6 rows. That means this is your Cartesian product. There is no keyword for Cartesian product. How to identify? How to identify? When from clause has more than one instance. When from clause has more than one instance, then it is a what? Cartesian product only. It's a simple definition. It's a simple definition such that whenever from clause has multiple instances, it is a Cartesian product. But earlier, before 1999 join, you have to write very clearly that select star from department, cross product, select star from EMP. But here there is no keyword, it's a shorthand joins they are. Simply you can say that like this, it's going to give you Cartesian product. Okay, now let us see one example. To avoid Cartesian product, what is required? Join condition is required. Join condition is required. So when you get the Cartesian product, when Cartesian product occurs, this is a very important point. So when the Cartesian product occurs, when from clause has more than one instance, more than one relation instance, without having any join, without having any join condition, without having any valid condition or join condition, then you are going to get a what? Cartesian product. So the reason behind Cartesian product is that it's what? What is that? Whenever from clause has more than one table instance without having any valid condition or any valid join, it is a Cartesian product. Okay. Now, in order to avoid the Cartesian product, what to do? Please see now. So, this is our concept. To avoid Cartesian product, you may use natural join, or you may use equi-join, or you may use theta join, or you may use self-join. These are the four varieties of joins: natural join, equi-join, theta join, also called as a non-equi-join, non-equi-join, or theta join, or self-join. EMP also has 3 rows. Where? So EMP has 3 rows and department has got 2 rows. Therefore, it is a 6 rows because 2 into 3 is equal to 6. Now come here. So this is a very important, friends. Very important. Now I am going to give you a shortcut to you. Now you see, natural join, consider all common columns, especially we take care of primary key and foreign key. Primary key and foreign key. Okay, this is a very important point. That's why minimum of natural join is equal to maximum of natural join is equal to, depends on, this is your shortcut, depends on child instance. That's it. So minimum and maximum size of natural join depends on child instance only. If you would able to identify child table, your answer will be in your hand. Okay, so let us write a concept that is like this. There is a table R which consists of AB, and there is a table S which consists of AC, 10 20 10 20 10 20, C1 C2 C3 C4 C5 C6, and 10 B1 20 B2 30 B3. Observe carefully, friends. I am saying this is your primary key, this is your foreign key. Now tell me, Select star from R, natural join. Select star from S. Tell me, minimum how many tuples you are going to get, maximum how many tuples you are going to get. Please observe. This 10 can map with this 10, this 20 can map with this 20, this can map this with that, 20 can map to this, 10 can map to this, 10 can map to this. So how many rows you are going to get? 1, 2, 3, 4, 5, 6, 6 rows. Minimum also you will get how many rows? 6 rows only. Why? That all depends upon your foreign key instance, because every foreign key value is a subset or equivalent to your primary key value. That is the reason. Every foreign key value is a subset or equivalent to primary key value. So I cannot keep here 50. Therefore, 50 must be available in a master table, that is R. Therefore, instead of mapping, need not mapping like that, simply I can say answer. How I can say answer? Please observe now. I say, for example, R of AB has 100 rows. This is your 2010 gate question. And I say S of AC has 1000 rows. Okay. And now this is the primary key. This is the foreign key. Now I am asking, what is R natural join S? Anybody? What is R natural join S? R natural join S is nothing but which table? Foreign key table. The previous also, when you talk about the child is nothing but foreign key table only. Foreign key table is called as a child instance. Now here also you say, I am saying this is your primary key, this is your foreign key. Though R has 100 rows, your R natural join S is equal to how many rows? That would be the minimum and that would be the maximum. So how many rows you will have? Very nice. It is a what? 100 only. As a child has every row has to have the combination with your master. Hence, therefore, you cannot have more than this unless and until you have nulls. Nulls we are not considering. Ignore nulls. So you say that you are going to get only 100 rows only. Clear? Now you look at another example here. I say R of Mn O S of MPD. M is a primary key. This M is a foreign key. R has 100 rows. S has 0 rows. Now, if I am asking you, what is R natural join S? What is your answer? You do not require any kind of data. What is your answer? Straight away you can say what is your answer. What is your answer? Simply you can say your natural join, the minimum and maximum size of join whenever primary key and foreign key is mentioned. It always depends on your child instance only. So what is your child instance here? S is a child instance. As S has a 0 rows, our answer is 0 only. 0 comma 0 is your answer. That is the minimum and that is the maximum. Clear? Now let us look equijoin now. Yeah, child instance is 0. Please look at. R has 100 rows, S has 0 rows. Therefore, your answer is 0 only. Now I say equijoin based on common column and common data. This is a point number 1. Point number 2, where clause is used to represent equijoin. And next point is equal to is equijoin operator. These are the three important conditions based on common column and where clause is required and is equal to is the join operator. Okay, let us take one example. The department and employee, department number 10, 20, 30, employee number E1, E2, E3, department number I am bringing here as a foreign key 10, 10 and 20, E4, 10. Now I am writing a query here that select asterisk from EMP comma DEPT. How many rows? Select asterisk from EMP comma DEPT. How many rows? Select asterisk from EMP comma DEPT. How many rows? This statement will give you how many rows? This statement will give you these 3 rows are being mapped with these 4 rows. Now you will get 12 rows. Please observe. Employee 4 rows, department 3 rows. Simply I have left that as like that only. Select star from EMP comma DEPT. It is going to give you 12 mappings. But we want to continue because to avoid the Cartesian product there is a mandatory condition of join. Therefore, where EMP dot common column department number is equal to DEPT dot department number. Now this 12 will come here for further mapping. So 10 10 is matched, 10 10 is matched, 20 20 is matched, 10 10 is matched. So your answer is how many rows here? 4 rows. See friends, this query first we try to give you 12 rows, but we represent using a concept of a join condition here. This is turned up to provide only 4 rows. Next one, there is a R which consists of AB and which consists of AC, 10B1, 20B2, 30B3, 10C1, 10C2, 20C1, 20C2 and 10C3. This CA is a foreign key here. Please observe now. Select asterisk from R comma S. If I leave like that, 3 into 5, you will get 15 tuples here where R dot A not equal to S dot A dash rows. Please answer to this question, all of you. Select star from R comma S. It will give you 3 rows here, 5 rows here. It will give you 15 rows. If I put a condition that R dot A is equal to S dot A, then how many rows we are going? R dot A not equal to S dot A, then how many rows we are going to get? Yes. What is your answer? Please respond. Where R dot A not equal to S dot A, how many rows? All of you, please respond. All of you, please respond. Where R dot A not equal to S dot A, how many rows? The answer is, please see, there are total 15 rows. How many are common? How many are common? 5 rows are common. Yes or no? The remaining are uncommon only. Therefore, your answer is how much? 10 rows. This is the beauty of that. Please observe carefully. It's not 0, it's a 10 rows. Clear friends? Because Your 15 will be converted into 10, which means you are having a 10 unequal mappings, 5 equal mappings, 10 unequal mappings. There are 15 rows, 5 equal mappings. So 1, 2, 3, 4, 5, and the remaining 10 are unequal mappings. Okay, friends? Come to, or you want me to explain once again? Please see carefully. This 10 can map. All of you observe carefully. If you have doubt, I will explain like this. Please observe. This is very, very important query. Please observe. This 10 can map with this 10 is equal to I don't mind. This 10 can map with this 10, no problem. But this 10 cannot map with this 20. Therefore, you will get 10 B1 20 C1, one tuple. Please observe. This 10 cannot map with this 20. Therefore, 10 B1 20 C2. For any kind of a join, the first step is cross product only. From there, we are trying to equalize. Next, we have 10 can map with this 10. Next, come here. 20 cannot map to this. So, bring it. So, 20 B1, sorry, 20 B2, 10 C1. If you write like that, you will get 10 rows. Because total mappings are 15, 5 are equal mappings, remaining are unequal mappings only. Clear, all of you? Yes, you're right now. Now, come here. Next one is left outer join. I am saying R with AB, S with AC, 10 B1, 20 B2, 10 C1, 20 C2, 30 B3, 40 B4. I am asking select asterisk from R comma S where R dot A is equal to S dot A. How many rows? This will give you 4 rows into 2 rows, 8 rows it will give you. Please observe all of you. The first statement will give you 8 rows. If I make it equalize, how many rows you are going to get? Where R dot A is equal to S dot A. How many rows you are going to get? Where R dot A is equal to S dot A. How many rows we are going to get? So this is equal and this is equal. Then we are going to get only 2 rows. What are the 2 rows? A here, B here, A here, C here. Please observe. 10 B1. It is matched with this 10. As I am asking, this is the common column. R dot A is equal to S dot A. And I am saying that this is your primary key and this is your foreign key. Don't forget that. And this 20 can have mapping here. That is a 20 B2 and 20 C2. Clear all of you? If I attach plus C is outer join operator, please observe carefully. Plus C is outer join operator. If I add plus here, what will happen? It get back the data which is not having a mapping in the R. Please observe. It get back the data which do not have mapping in the R. There is no keyword like left outer join, right outer join, full outer join. This is the shorthand operator. So therefore, it is going to give you 30 B3 and 40 B4 and you are having null null. Clear, friends? Observe carefully. Because of this plus, it is going to give you the extra 2 tuples. So plus is your outer join operator. Plus is your outer join operator. Come here, next. I say right outer join. Here also plus is the only right outer join operator, same. Now I say there is a R which consists of AB, 10b1, 20b2, there is a S. For example, I say C and D or A and D. I am saying here 10d1, 10d2, 10d3. If I'm asking a query here, select asterisk from R comma S where R dot A of plus is equal to S dot A. Otherwise, let me write like this. Where S dot A, where S dot A of plus is equal to R dot A. First, it will give you common data. So what is the common data it will give you? Please see. 10b1, 10d1. Next, again 10b1, 10d2. Next one 10b1, 10d3. Now this plus is responsible to give the data from other side. So which side? R side. So again you will get what? Extra tuple sets which are dissatisfied there like this. This is your R, this is your X. Yeah, there is a question. You will solve those such kind of questions in evening class. Evening class is meant for this kind of questions, how to form this kind of questions. So evening you will solve them. So I will show you some of the examples now. You please go ahead. So friends, finally we learned what? We learned few important joins like Cartesian product we learned, and we learned equijoin, and we also learned non-equijoin. Non-equijoin is nothing but theta join only. Now we learn left outer join. We also learn the right outer join. But if I write a query, select star from R comma S where R dot A of plus is equal to S dot A of plus. What kind of a join it is? What kind of a join it is? What kind of a join it is? Please observe carefully. Where please observe where R dot A of plus is equal to S dot A of plus. We all thinks that this is a left outer join. Sorry, this is a right outer join, and this is a left outer join. Therefore, totally you can call it as what? Full outer join. But in SQL after 1999, SQL after 1999, we don't have any full outer join. So it is invalid. Please observe. It is wrong. Either you can have left outer join or you can have right outer join, but you cannot write full outer join. Why? Because your foreign key value is a subset or equal to your primary key value. Therefore, it doesn't require any kind of extra tuple set at child instance. Okay, friends, any doubts so far? Any doubts so far? You can chat with me as this is a live class. Okay, so I'm go ahead. Yeah, come here. Self join. Self join is nothing but join to itself is a self join. For example, you please observe I say select star from R as R1, comma R as R2, where R1 dot A is equal to R2 dot A. So if you take a table here, there is a R which consists of 10, 20 and 30. What is the output of this? You observe. The output is this table is going to represent in two times, two instances. One instance R1, one instance R2. So what is your R1? Same data. 10, 20, 30. Equal, we are asking equal operator. What is your R2? Same data. 10, 20, 30. What I am asking is equal to between mapping them. So this 10 and this 10 can map. So I will get 10 here. This 10 to this 20 cannot map. So you don't get. This 10 and 30 cannot map. But 20 cannot map. But 20 can map. 30 can map. So this is how you can represent join to itself is a concept of what self join. You can have condition to yourself. So what is a real-time example of self join? Let me give you. Real-time example of self join. Employee table, please observe. An employee can be a manager. An employee can be manager to manage departments. This is the real-time example. Please observe carefully. Employee table, employee E1, name X, his role is a manager. He is working in department number 10. Now there is an employee 2. His name is X. His role is a clerk who is working in employee department number 20. The first column is employee number. Second column is employee name. Third column is a job. Fourth column is a department number. Fifth column is who is your manager. Please observe. Who is your manager? So I am writing my manager is nobody. I am the owner of the company. Who is the manager for this 20? The guy is called E1. Sorry. The guy is called E1. So what do we say? Please observe. E2 manager. Who? X. Please observe. E2 manager is X. Please observe. E1 do not have any managers as he is running the company on its own. E2 by name Y is working as a clerk under 20 department. Who is the manager to him? E1 is the manager. Please see. E1 is the manager. Who is his manager? X is the manager of E2. So if you want such kind of interlinking, it is called self join. So it's a very beautiful self join can be used in many other places. Single join can be represented in a multi varieties. That's in that case you can observe self join. This is a real-time example. What is that? Who is the manager of E1? An employee in that company only, nobody else from other tables. An employee in that company is acting as a manager. So who is the manager of E1? So come to that table, check that this E1 and this E1 is matched. Then I can understand that he is a manager who is by name X. He is a manager to E2. In such cases, self-join is very much useful. Okay, friends. So that is today's concept. So we have learned what is the importance of join and what are the different types of joins. All joins are based on either inner joins or outer joins, and all joins are based on either two-way joins or n-way joins. So what is n-way join? Let me give you one example on n-way join. I'm writing n-way join now. So what is n-way join? R AB, S, AC, T, CD. Please observe carefully. 10B1, 10C1, 10C2, C1 D1, C2 D2. If I ask a query, select asterisk from R comma S comma T. I'm getting from three table instances and I'm saying where R dot A is equal to S dot A, N, one more join linking I'm doing, and S dot C is equal to T dot C. Then this kind of a joins are called as what? N-way join. So n instances will come into the picture to form the query. Therefore, this is your foreign key here and this is your foreign key here. So likewise, you can link up multiple number of tables and you can write the join using equal operator or unequal operator. Okay friends, so this is the concept of a joins. Evening on special class, we are going to walk out on the problems whatever we learned in this lecture. And you see that the evening class also will be live on YouTube. You can watch through YouTube. Also, you can watch through special class, no problem. And tomorrow, our concept on YouTube from 2 p.m. is subqueries. How to retrieve topmost three employees or highest earning employee, that with such kind of things we are going to learn in tomorrow's session. Stay tuned to us. Take the admission in Unacademy. Use my referral code SANKARA to get the 10% off. And subscribe to Unacademy channel and YouTube Let's Crack Gate channel. Let's crack it. We'll meet in the evening session.